The discovery of a new dwarf planet may bring us closer to Planet 9. A new chapter in our understanding of the solar system has just begun. Astronomers have recently discovered a previously unknown dwarf planet in the outer regions of our cosmic neighborhood. Named 2017 of 201, this distant world immediately drew attention due to its extremely unusual orbit. Not only does it take an astonishing 25,000 years to complete one trip around the Sun, but it also moves in a wildly eccentric path, swinging from just beyond Pluto to nearly 1,600 times the Earth-Sun distance. But the surprises don't stop there. The unique orientation of this dwarf planet might actually offer a crucial clue in solving one of astronomy's biggest mysteries, the hunt for the elusive Planet 9. So stay with us until the end to understand how this discovery could be the breakthrough we've been waiting for. Beyond Neptune, the untold regions of our solar system. In popular understanding, the solar system seems to end with Neptune. While it's true that Neptune is the eighth and farthest known planet from the Sun, our solar system extends far beyond it. Well past Neptune's orbit lies the Kuiper Belt, a region populated with icy bodies and remnants from the formation of the solar system. Even farther out is the Oort cloud, a hypothetical shell of icy objects thought to be the source of long-period comets. Just for reference, one astronomical unit, AU, is the distance between the Earth and the Sun, about 150 million kilometers. The Kuiper Belt starts at around 30 Australian dollars. Though confirmed only in the 1990s, the Kuiper Belt still holds countless unsolved mysteries. We've only discovered a tiny fraction of the trans-Neptunian objects, TNOs, believed to be out there. Yet even from that small sample, astronomers noticed a peculiar pattern. Many TNOs seem to group together in one specific region. This odd clustering led scientists to propose a radical idea: the gravitational influence of a large, undiscovered planet. A true ninth planet. Planet 9. Discovery of 2017 of 201. Now, enter 2017 of 201, a newly found dwarf planet that could either support or challenge the Planet 9 theory. The discovery was made by a team led by Saikiro Shank from the Institute for Advanced Study in Princeton. They analyzed data collected between 2014 and 2018 by the Dark Energy camera mounted on the Blanco telescope in Chile. They noticed a faint point of light slowly moving across the sky. Upon further inspection, including matching it with archived images from the Canada-France-Hawaii telescope, the team confirmed they had identified a previously unknown celestial object in an extremely wide and eccentric orbit. Pluto's cousin with a wild orbit. But what makes 2017 of 201 truly remarkable is not just its discovery, but its properties. First, it's huge, around 700 kilometers in diameter. That makes it not only one of the largest known objects in the outer solar system, but also a dwarf planet, due to its nearly spherical shape. Second, its orbit is extraordinary. Its farthest point from the Sun is over 1,600 Australian dollars, while the closest point is about 44 Australian dollars and 50 cents, close to Pluto's orbit. It takes a mind-boggling 25,000 years to complete just one orbit. Even more remarkable is the timing. The only reason we could spot 2017 of 201 is that it recently passed its closest point to the Sun and Earth in November 1930. Coincidentally, that's the exact year Pluto was discovered. Since then, 2017 of 201 has been drifting farther and farther away and is now about 90 Australian dollars and 50 cents from the Sun, making it one of the most distant objects in the solar system visible in reflected light. What it tells us about Planet 9. So how does all this tie back to Planet 9? The current theory for Planet 9 is based on the clustering of objects in the Kuiper Belt that share similar orbital alignments, often around 60 degrees. But 2017 of 201 doesn't fit that mold. It's perihelion, the point closest to the Sun, is tilted at 306 degrees, far outside the expected range. This raised an important question. If Planet 9 exists, why doesn't its gravity affect this dwarf planet's orbit? To answer this, Shank's team modeled the gravitational effects of a hypothetical Planet 9. The results were telling. Without Planet 9, 2017 of 201's orbit remained stable for over 1 billion years. But with Planet 9 in the equation, gravitational interactions would eventually push it too close to Neptune, dooming it to be ejected from the solar system in about 100,000 years. That means 2017 of 201's very existence may contradict the Planet 9 theory, at least in its current form. Could Planet 9 still exist? So is the Planet 9 hypothesis dead? Not necessarily. Researchers like Mike Brown and Konstantin Batygin from Caltech are still exploring possibilities. They ran detailed simulations with different masses and orbital parameters for a possible 9th planet, trying to find a configuration that best explains the observed orbits of 11 extreme TNOs. They created a sky map that narrowed down the most likely location of Planet 9. If it's similar in mass to Neptune, about 6 Earth masses, it would orbit with a semi-major axis of around 380 Australian dollars, ranging from 300 Australian dollars at its closest to 450 Australian dollars at its farthest. In other models, a lighter Planet 9, about 2.2 Earth masses, could swing in as close as 85 Australian dollars. They also found that its orbit is likely tilted at 16 degrees from the plane of the solar system. The search continues, and you can help. So where's Planet 9 now? If it exists, astronomers believe it's currently near the furthest point in its orbit, meaning it's very faint and hard to detect. It moves slowly and blends into the background of stars, making it difficult to spot. But here's the exciting part. If Planet 9 is bright enough, it might already appear in archived sky survey images, and anyone could find it. Since 2017, a citizen science project has been underway where volunteers can search telescope images.